First, Professor Olli Seppänen of Aalto University gives us a brief overview of the ACTOR project.
Hello, my name is Olli Seppänen. I'm the principal investigator of ACTOR, Automatic Coordination of Construction Projects, research project which is a collaboration between Aalto University and VTT, the research partners and 4 companies, Carinafour, Flow Technologies, KONE and Trimble Solutions. The program has been funded by Business Finland and the European Union Next Generation EU. We started the project because just 20 to 30% of construction site time spent adds value. And our goal is to increase this value adding time by 20% through technology. Our approach is improving real-time situational awareness by using tools like robots, sensors, AI, XR and standardized data. The solutions you are going to see today from the company partners include solutions related to logistics, smart elevators and recording site flow, scheduling systems, and solutions related to the robotic automatic data collection. In addition to this, we have a lot of research coming up, but we will have separate events to discuss our research results. Welcome and enjoy.
Could we reach the same level of material management as the shipbuilding industry? Ari Viitanen of Carinafour explains how to automate the material management workflow with their CALS platform.
In the ACTOR project, we research and develop further our CALS material management platform. So if we looked at what CALS is actually what it's about. So first, in the first box, we are collecting the construction material part lists. We can take it from the BIM model or we can take it manually from another sources. So there we are getting this space-specific part list. Next thing is that we are connecting the part list to the schedule. So work planning or the project planning. After the second box, we have the scheduled part list, which is actually demand. It means that we know that what materials are needed, when they are needed, how many needed, and where they are needed. Okay, now we move to the third box where we are doing the supply chain integration. There we are sharing the forecasts, running the material recalls, and getting the material confirmation from the network. After the third box, we know that we have the material availability. After knowing the material availability, we are connecting the logistics process, where we are actually defining that how the materials are delivered, in which kind of batches, which kind of transportations, are we using warehousing, etc. There we are actually guarantee that the materials are on the assembler's hand when needed. And we are also resourcing the logistics process and take care that the logistics process is also safe. And after the materials are delivered, everything is installed, we have collected the deviations, we have run the continuous improvement. So after all of the whole process, we are able to do the digital delivery. Means actually 2 things. We can deliver to the asset owner that which materials has been used in the project and which locations. And we know also the process, how we have delivered, how we have defined, how we have run the logistics. So we have this the logistic, as-built logistics model as well. So from the model, from the logistics process model, we can utilize it to further develop the whole process. And in the ACTOR, the main focus was that how to automate the information sharing. Today, we are doing all of this with the emails, we are doing that with the telephone calls, and the digitalization utilities, how we are using the digitalization, it's a very low level today. But in the future, okay, time to time we need a telephone or emails, but the idea is that the material management that will be in the digital platform, we have the data, how to develop the system further, how to be better tomorrow what we were yesterday. And that was the aim, standardize, stabilize, automize. And that's the CALS 3.0, what has been researched and developed under the actor. Thank you.
How could elevators be used for construction management and optimization? Let's watch a video by KONE about SiteFlow, a digital platform providing that capability. And then Ulla Tikkanen will elaborate on the benefits of the solution.
What if you could boost productivity by, say, 8 hours per day by improving the vertical logistics at your construction site? What if you could preempt and prevent elevator bottlenecks in real time? What if you could improve the flow of people and materials on site by providing actionable insights to all workers? What if you could significantly reduce the risk of delays? Get up and go with KONE SiteFlow. Manage and monitor your elevators remotely. That means instant insights anytime and complete control anywhere. Permit or limit floor access in line with the latest on-site developments. You can even prioritize the elevator for the most operation-critical workers, allowing them over 4 times faster service. Quickly identify and fix any issues with the help of AI and real-time notifications. Share information and updates with everyone via the KONE SiteFlow app. Get people and materials to the correct floor with minimal hassle. So, how does it work? We use RFID data to enrich elevator, people and material flow data, combined by advanced AI technology. Over time, KONE SiteFlow calculates how to best optimize the system for your site's specific needs. The installation is simple, requiring only helmet tags. Attach, scan and go. We'll handle the rest. KONE SiteFlow provides actionable insights to increase site productivity. It equips you with the tools to fully control elevators during construction. Detect and react to minor issues before they become major problems. With its help, you can cut back on the productivity cost of all the little moments lost. A 2-minute delay here, a 5-minute wait there, adds up to hours upon hours across the lifespan of a project. And that's just for one single worker. KONE SiteFlow, giving your efficiency the lift it needs.
So, to conclude and to align with actor goals, I would like to mention 4 things. By integrating KONE construction time elevators as part of your vertical site logistics, you can save up to 46K per month per elevator by moving workers and materials faster. Secondly, our digital solutions can help to maximize the elevator logistics capacity, both KONE elevators and traditional construction hoists. According to studies conducted with our partners, digital tools can significantly reduce time in looking for tools and equipment. And finally, read more if you're interested and book a free demo from our website.
One of the use cases for robotics in construction is data collection. Kim Nyberg of Trimble discusses automated data collection and digital collaboration boosted with robotic technologies.
For the last couple of years we have been working on the Actor project, trying to get robotics into the work sites. Trimble has been focused on automated data collection. We have been using Boston Dynamics Spot robot, which we have then equipped with 360 cameras and laser scanners, LiDARs, and so on. And then we also have developed remote operation software for remotely controlling the robot using a web interface. which means that we can control a robot anywhere in the world just using a browser. In Finland, we have been focusing mostly on the construction industry, and then our international tasks have been focused around mining. Another aspect we have been working quite heavily on is real-time collaboration. So once we get the data from the field into our system, into Trimble Connect, into Tekla Structures, we have enabled something called Trimble Live Sharing as a backend solution and live collaboration, which allows for real-time collaboration around the model, avoiding meetings to talk about clashes and instead solving them in real time. And of course, these changes can then be sent back to the field as well. One of the many things we have done also is utilizing GNSS, that is GPS hardware, so that we can plan missions outdoor using Trimble maps. And so an operator can sit at an office, plan a site visit, and then anyone that can drive a car can basically take the robot out on the site, press a button on the mobile phone, and then the robot will autonomously walk the predefined mission and collect the data, either using 360 imagery, LiDAR, or point clouds. And then once it's in Connect, we have software that can automatically classify the material, align it automatically, and from that we can then do modeling either based on the point cloud or then automate the process. So this enables automatic collection of data and a better situational picture for the construction companies. We have also worked with XR hardware. We have tested out the Vario XR3 for data collection, and then various headsets for immersing yourself in 360 images, for example. And we have even been testing controlling the robot remotely from within a headset, so you can kind of immerse yourself really in real time and see a live video feed from the construction site, even if you're in another country or other part of the country. And this really reduces things like travel, so reduces CO2 emissions. We can get experts on site without them actually having to physically be there. On the autonomous exploration side, we have been working with XIN Technologies. They have a LiDAR, rotating LiDAR system that can create almost in real time point clouds. And one of the world first that was done during the Actor project, that we scanned a multi-story parking garage in just about 10 to 15 minutes, something that traditionally would take hours to do with the traditional methodology.
Digital twins of buildings have been in the headlines for many years, but can you imagine a digital twin of a construction project? Our last presenter, Tomi Pitkäranta of Flow Technologies, explains what their company has done in Actor to achieve this goal.
Hello, and welcome to this webinar. My name is Tomi, and I'm here to present our results. But first, a bit about us. Our Actor project team consists of members from Flow Technologies, which is our parent company, SkyDrive, our construction software company, and our affiliate entity, Fiva, which is general contracting company operating in southern Finland. Our objective for the project was to define how digital twin of construction process can A, improve site productivity, and B, support development of a construction production system. This project was done in 7 work packages. Each work package had their own results about understanding current state and defining method for optimal state. Here I present a brief summary of the whole results. First, we learned about how to capture the relevant data from the site, and then to understand how to use this data for the production, and also how to visualize it to help the production. The huge thing in the project was to understand how to actually manage all the information related to digital twin of construction processes. Additionally, here in work package D, we developed a method for automating production planning based on design. For work package E, it was all about understanding how the site should be managed, what are the structures there, and who will be doing these managing decisions. Then, in the visual management, we focused on enhancing the communication of tasks and about tasks, so what to do and how to communicate that information. And finally, in the work package G, we defined a model how to achieve a win-win situation between general contractor and subs. Overall, all the learnings of the project have been taken into account now that we develop a construction production system that we do here in SiteDrive. That's all. Thank you. Feel free to contact. I'm looking forward to discuss more about this with you.